given the function h as an equation where h represents the number of HIV infections over time, but we also have a graph of the function. So basically what you see down here, this red curve, right? This red curve represents the graph of this equation. So if we were to substitute in different numbers for t, we'll get corresponding values for h, and so we get a whole bunch of points. And then when we plot those points and connect it with a line, it gives us this curve. So let's take a look at question E. Question E and F focuses specifically on looking at average rates of change. So the average rate of change between points tells us how fast the function is increasing over a specific interval. So question E says, is the function h, which is the number of HIV infections, is it increasing faster between t equals 5 and 10, or is it increasing faster between t equals 10 and t equals 15? So I'm going to write this down in interval notation. Is the function increasing faster between t, I'll call that t sub 1 equals 5 years, and 10 years? I'll call that t sub 2. So this is basically 1995 and 2000. So is the number of HIV infections increasing faster between 1995 and 2000? Or is it increasing faster between t equals 10, so I'll call that t sub 2, and 15, we'll call that t sub 3, okay? Or so is it increasing faster between 1995 and 2000, or between the year 2000 and the year 2005? So to answer that question, you can either calculate the average rate of change, so we can actually stick it into the formula and calculate the average rate of change between those points. Or if you have a graph, you can actually just look at the graph. So let me show you graphically how you can see where the function is increasing faster. So let's plot the point where t is 5. So when t is 5, it hits the graph right there. And so I'm going to call that point A. And when t is 10, it hits the graph about right here. So I'll call that point B. And then when t is 15, it hits the graph right here. So let's take a look at the first interval between 5, oops, let me use my highlighter here. So between 5 years and 10 years, to see the average rate of change visually, what you're going to do is connect the points with a line. And let me use my highlighter. Excuse me, my pen, not my highlighter. So if I connect the points A and B, you can see the steepness of that line. It's pretty steep, okay? So the function is increasing relatively fast. So the number of HIV infections is increasing at a certain rate between 1995 and 2000. But if I compare that to 2000 and 2005, I'll use a red line here. If I connect point B and point C, hopefully you guys can see that visually the function is increasing much faster between points B and C. So over the interval where T is 10 and 15 years, you can see the red line is a lot steeper than the green line. So visually and graphically, what this is telling us is that the number, let me use blue here, the number of HIV infections, okay, is increasing faster between t equals 10 and t equals 15, all right? And the explanation for that is we can see from the graph that the line that connects the points between t equals 10 and 15 is much steeper than between the points where t is 5 and t is 10. In the next question, question F, will actually calculate that rate of change. So we can actually come up with a numerical value that represents the steepness of those two lines. So question F here asks us exactly how fast is the number of HIV infections increasing between t equals 5 and t equals 10? And let's calculate the average rate of change between that. So we go back to the equation here, we can actually calculate how fast the number of HIV infections is increasing between, and I'll write that down again in interval notation, between t equals 5, so I'll call that t sub 1 again, and t equals 10, which is t sub 2. Okay, so to calculate the average rate of change, just remember the formula, the average rate of change. In this particular problem, instead of using x and y's, I'm going to use t and h, okay? So our input value is our t, so t sub 2 minus t sub 1. And we divide that into h sub 2 minus h sub 1. So we know what the input values are. We're looking at the average rate of change between year t equals 10 and year t equals 5. And now what we need to do is we need to figure out what is, I'll use function notation here, we want to know what is the number of HIV infections after 5 years, okay, and that will give us h sub 1. We need to figure out what's the number of HIV infections when t is 10 years. So that we're calling h sub 2. So all you have to do is substitute this into the equation. Wherever we see t, we're going to input that input value. So the first one here, we're going to input 5. And then we'll do the same thing when t is h. So that's 2.3 times e to the 0.1343 times 10. Okay, and then let's see what that is. So H of 5 is equal to 4.5 million cases, and H of 10 is 8.8 million cases. So now I can just substitute that into the formula up here. So H sub 2 is 8.8, and H sub 1 is 4.5. So now I can calculate the average rate of change. So subtract the difference in the output value and divide it by the difference in the input value. So that gives us 0.86, and then let's write down the units so we understand what this average rate of change means. So it's a positive number. So this tells us that between, so let's see here, when t is 5, that's the year 1995. And when t is 10, that's the year 2000. So between 1995 and 2000, the number of HIV infections increases, and I say increases, that's positive, by 0.86 million HIV cases per year. And that's really important that we write per year because it's a rate. So a rate is always some unit per some other unit. Okay.